Assalamu alaikum. I mean, again, I'm sorry for selecting such an odd time, but I can't help it. I will avail as uh, time as possible and whenever it is possible. What we have to cover in the rest of the time available from chapter 6, I have already shared this article, notes on this article, area between two curves, and most of you are familiar with this idea already. Volumes by slicing, disk and washers, that is the second thing that I will be considering in chapter 6. Then leaving out volumes by cylindrical shell, we'll go to length of plane curve and some part area of surface of revolution. This I will cover in chapter 6, and in chapter 10, parametric equations, how a curve is represented in parametric form, and how the tangent line and the normal line are obtained from that parametric form, and arc of length for parametric curves, which is already considered in 6th chapter without parametric curves for general curves, but here we'll consider arc length for parametric curve. We'll consider some polar coordinates very briefly, although this article is very lengthy and lots of things are there, but I'll consider only selected part of that, and that I'll include in my notes, lecture notes that I'll share with you. And next thing in the 10th chapter is tangent lines, arc length, and area of polar curves. But one more thing. Conic sections. Some of you who are coming from intermediate background, they are well aware of equation of circles and ellipse, parabola, hyperbola, etc. But those who are not familiar, we have to consider this. So Article 10.1, part of 10.2, 10.3 and 10.4, only part of 10.4. So this is what we have to do, and I'll record lectures as and when I will be good, well enough, and I have got time. Whether the time is suitable or odd time like this. So these are the things that we have to cover. So I have shared this file, I suppose. There are parts of pages of the book I have accumulated in this document. Application of definite integrals, area between the curve. The problem is that if over an interval x is equal to a to b, there are two curves, y is equal to fx and y is equal to gx, such that the value of fx is greater than the value of gx throughout the interval. Theoretically, what we do is that we make vertical strips of the region between the two curves, and the difference of the function values is the height of one strip and the width of that strip multiplied. The height gives you the area of this strip, and adding all these areas together give us a formula for area between two curves. So when we use this formula, area between curves fx and gx, we have to verify whether function values of f are greater than function value of g or not. If it is the case, then we use the formula directly. Like in this example, where you have to find the area, between curves y is equal to x plus 6, that is this straight line, and the curve y is equal to x squared, and between x is equal to 0 and x is 2. So y is equal to x plus 6, which is a straight line. Here function values are larger as compared to y is equal to x square between x is equal to 0 to 2. So this is just a simple, straightforward upper function minus values of the lower function integrated between the interval given. So this integration is very simple. मैंने इसको हाथ से भी करके टाइप किया हुआ, लेकिन I hope this is very simple and you don't have any problem in solving this. This is y is equal to x plus 6 and this is y is equal to x square. Over the interval 0 to 6, 0 to 2, x plus 6 has a larger value, whereas x square has lower value shown in the graph. So fx minus gx integrated values from x to 0 to 2 evaluated and the area obtained. Another example, find the area of the region that is enclosed between the curve y is equal to x square. Now y is equal to x square is a parabola and the line y is equal to x plus 6. Now in this we are not given the values of from x is equal to what to x is equal to what. In this case we have to find the point of intersection of the two curves. That is y is equal to x plus 6 और y is equal to x square को हम इक्वेट करेंगे. इक्वेट करके जो इक्वेशन बनेगी उससे x की वैल्यू निकालेंगे and then from x value minus 2 to x value 3. The region included between these two curves is shaded, and so again y is equal to x plus 6 for this shaded region has y values larger than the curve y is equal to x square, जिस पे y values जो है वो smaller है. So in this case the problem was the same, but limits of x are different. They are not given in the question. We have to find them from the given curves where they intersect. We have to find the point of intersections, and after that we integrate the same function x plus 6 minus x square, but the integration limits are different, and this is it. To find the limits of the integration for the area between given curves is explained here. I think it is not rocket science, and we will consider this problem in these steps in problem solving. Of course, in some cases, the two curves given will not intersect, in which case we will have to have the boundaries of x from where to where it is varying. But when the curves are intersecting and you have to find the area between them, like in this next example, we have to find the area enclosed between these two curves. X is equal to y square and y is equal to x minus 2. Y is equal to x minus 2 is a straight line, whereas x is equal to y square is a parabola of different type, which is opening rightward. Now, in this case, the problem is changed, and instead of considering area formula previously, which was x is equal to a to b, function which has larger values minus function which has smaller values integrated over x. Now we see that this region is bounded between the given curves. We see that on the straight line, the x values are larger, whereas on the parabola, x values are smaller. So it is the integral will change from being depending on x, it will now be considered depending on y. So y is equal to c to y is equal to d. Function of y, which has values greater than function of another function of y, and integrated over y. So this function is x is equal to y plus 2, whereas this function can be written as y is equal to square root 2. So, but we will consider x is equal to y square and x is equal to y plus 2. What are the integration limits? In this case, integration limits, again, we have to find the point of intersection. So point of intersection निकाल के limits on y will be obtained. So this point of intersection has y value -1, whereas this y value, this point of intersection has y value 2. So this becomes what? This becomes integral y is equal to -1 to y is equal to 2. The function on the right side is now x is equal to y plus 2. So y plus 2, function of y, minus x is equal to y square. So this will be integrated over y, and the result will be obtained here. Yes, of course, there is an alternate approach which is described here, but I will suggest that instead of doing this problem with integration over x as it is done here, it is better to do this way. Let us see what results we will get. The integral will be y squared plus 2y minus y cubed by 3. In the limits, -1 to 2. So for 2, it will be 4 plus 4 minus 8 by 3 minus y is equal to -1, and it will be 1 minus 2 plus 1 by 3. So 8 plus 1, 9, minus 8 by 3 minus 1 by 3, 9 by 3. Am I doing it correctly? 4 plus 4 for the upper limit, minus 8 by 3. Then lower limit, -1 square is 1, -1 into 2 minus 2 plus 1 by 3. तो 8 यहाँ से -1 यहाँ से जो कि +1 होकर 9 हो जाएगा, -8 by 3 यहाँ से और -1 by 3 यहाँ से. So 9 minus 3 is equal to 6. Now we are getting the result 6 by converting this problem of integrating over y, where they have done it in two ways, and the area is coming out to be different. Perhaps I'm doing something wrong. Yes, I have done something wrong. Y का इंटीग्रल जो है y स्क्वायर अपॉन 2 है. Y स्क्वायर अपॉन 2 होने की वजह से this will be 4 by 2 यानी 2. This will become yes 6. So 6 minus 8 by 3, or minus what? Minus 3 by 2 plus 1 by 3. So what we get is 6 minus 8 by 3 plus 3 by 2 minus 1 by 3, 6. Let me check 10 by 3 कहाँ से आ रहा है. So 6 plus 3 by 2 minus 3. So 3 plus 3 by 2. and that is indeed 9/2, the same result. So yes, I've got 9/2. Now what they have done here, uh, अगर मैं इसको x पे इंटीग्रेट करूं तो फंक्शन वैल्यू जो लार्जर है वो पैराबोला पे है कब तक from this line up to right side. On the left hand side there is no role of the line, so here it is just a1, it is just y is equal to root x above upper curve and y is equal to minus root x lower curve. So they have integrated this to get this thing on x. Integration is done on x. Within this region, they have done what? Square root x has larger value, whereas y is equal to x minus 2 has smaller values. So here they have taken integration with respect to x on this region, where this point of intersection has to be calculated, where x varies from 1 to 4, and root of x upper minus the straight line, and then integrated from 1 to 4, 19/6 added to 4/3. So this is a more complicated process as compared to looking this problem from integration on y angle, and this is an easier problem. So we have to, in problems, have decide कि भाई हमने क्या करना है. So reversing the role of x and y is one of the important things that we need to care about. So if we have this kind of situation where it is easier to handle the problem to the point of view that y x values are larger on a curve compared to the x values on the other curve, then we'll switch the role of x and y, and function of y, which has larger x values, minus function of y, which has smaller x values, and integrate on y instead of x that I have just demonstrated. And then find the area of the region enclosed between x is equal to y square and y is equal to x minus 1, integrating with respect to y that I have already considered. This much allow us to go to the exercise 6.1, and I have considered these problems for sample solutions. Find the area of the shaded region. I have taken it, this picture from there in the book, and here we are given this shaded region lies between the curve y is equal to x square plus 1 and the straight line y is equal to x. So you have to, of course, equate x square plus 1 is equal to x, and obtain the values of x that are satisfied with this. So they are minus 1 and 2. So that gives you the integration limit, and the shaded region is between minus 1 and 2 x values, and upper function x square plus 1 minus lower function x, and then integrate it over the limit minus 1 to 2, simplify, and we get the answer. In the second problem, it is also straightforward. Root x has larger values, whereas y is equal to 1 minus 1 by 4x has smaller values between x equal to 0 to 4. So oh yes, we'll be considering those problems जहाँ ग्राफ नहीं दिया होगा, मगर मैं जैसे मैंने प्रॉब्लम 2 सॉल्व नहीं किया, मैं सिर्फ ये बता रहा हूँ कि इस प्रॉब्लम को सॉल्व करने के इस प्रॉब्लम को सॉल्व करने के लिए यू हैव टू इंटीग्रेट फ्रॉम 0 to 4 x पे इंटीग्रेशन होनी है, square root x minus of 1 by 4x. So you can do that yourself. In question number 3, the region given जो उसका शेड था, उस शेड को मैंने 2 कलर्स में डिवाइड कर दिया, एक ग्रीन कलर में और एक ऑरेंज कह लीजिए इसको. तो इसमें एक तो y is equal to 2 लाइन है, और एक कर्व है और एक y इक्वल टू x लाइन है। तो मैंने इसको दो हिस्सों में डिवाइड किया है क्योंकि y इक्वल टू 2 जो है that is part of both regions, this region green and this region. ग्रीन रीजन में अपर वैल्यू y इक्वल टू 2 है, लोअर वैल्यू y इक्वल टू 1/√x है। तो ग्रीन में जो इंटीग्रेशन करेंगे उसमें मुझे ये पॉइंट कैलकुलेट करना है, y इक्वल टू 2 और दिस, इसको इक्वेट करेंगे 2 इक्वल टू 1/√x। तो 2 इज इक्वल टू 1/√x से मुझे x की वैल्यू 1/4 मिलेगी, यानी इस पॉइंट पर x की वैल्यू 1/4 है और इस पॉइंट पे x की वैल्यू 1 है, बिकॉज x इक्वल टू 1 से y इक्वल टू 1 आ रहा है। और I consider first integral from 1/4 to 1 for green part, 2 minus 1/√2, and get a value integrated over x. Then for pink region, it is x equal to 1 to x equal to 2. So integration from 1 to 2, 2 minus x integrated, and the area obtained. The total area is the sum of these two areas, and we get that. Problem number 5 is again a problem where graph is given, and y is equal to 2x is upper line, y is equal to x square is lower line between x is equal to 0 to x is equal to 2. So this is straightforward, so you can do it yourself. And here is the problem, which is similar to where we have to change the role of x by y, and then upper value is obtained from y is equal to 2x minus 4 as x is equal to y plus 4/3. So x is equal to y plus 4/2, sorry, minus ये पैराबोला जिस पे y स्क्वायर इज इक्वल टू 4x है, तो x इज इक्वल टू y स्क्वायर अपॉन 4. तो अब y पे इंटीग्रेट करेंगे तो y की वैल्यू 0 to 4 and we can get that. So then we come to the problem where somebody was worried कि जब रीजन नहीं दिया, ग्राफ नहीं बनाया हुआ तो क्या होगा. So that is question number 7 to 18. Look at question number 7. Y is equal to x square, and y is equal to x square goes like this. Y is equal to square root x, and that goes like this. Sketch the region, कह रहा है वो, enclosed by the curves, इन दोनों curves के दरमियान, and find its area. असल में दो कर्व नहीं दिए, चार कर्व दिए हैं. एक y is equal to x square है, एक y is equal to square root x है, एक x is equal to 1/4 है और एक x is equal to 1. तो मैंने ये चीज़ यहाँ पर गलत लिख दी है. This has to be 1/4. Now, what is the upper part? Upper function square root x. The lower function is x square, and you have to integrate between 1/4 to 1. I have not solved it. I have just shown you how to sketch the region, recognize the region. So 1/4 ये region जो है, अब I should color it clearly with a different color. कि मुझे according to the given condition, x is equal to 1/4 से लेकर x is equal to 1 के दरमियान इन दोनों कर्व्स के बीच में जो रीजन एरिया है वो निकालना है, उस रीजन का एरिया निकालना है, and that is done by this. Okay, that's good. Somebody has very quickly calculated this. I'm not interested. You should verify it yourself. Square root x minus x square को integrate करोगे between the limits 1/4 to 1 क्या आएगा? What is given in question number 8? Y is equal to x cubed minus 4x. Y is equal to 0, x is equal to 0, and x is equal to 2. Now x is equal to 0 is y-axis, x is equal to 2 is a vertical line, y is equal to 0 is x-axis, and x cubed minus 4x. Y is equal to x cubed minus 4x. मुझे इसका ग्राफ बनाना बहुत कोई मुश्किल काम नहीं है, बताया लगता है कि मुश्किल है. फॉर एग्जाम्पल x is equal to 0 के लिए this y will be 0, that means the graph will have a point here. Then x is equal to 2 के लिए 2 raised to power 3 8 minus 4 into 2 8, 8 minus 8 again 0. ये क्यूबिक फंक्शन है एंड क्यूबिक फंक्शन की शेप जो है वो बड़ी आर्बिट्रेरी की हो सकती है. But if you calculate few more points, यानी x is equal to half, x is equal to 1, for example, x is equal to 1 अगर करते हो, तो x is equal to 1 पर y is equal to x is equal to 1 पे y कितना आ रहा है? -3 आ रहा है. So I consider a graph like this. So upper graph is y is equal to 0, that is x-axis. Lower graph is y is equal to x cubed minus 4x. This function will have negative values between 0, x is equal to 0 and 2. If you go beyond x is equal to 2 on the right side and to the left side of x is equal to 0, then this curve may give you positive values. For example, x is equal to 3. So this will be 27. This will be 12. So x is equal to 3 के लिए क्या नहीं? सॉरी, मैंने उल्टा कहा कि 0 से 2 के दरमियान नेगेटिव वैल्यूज हैं इसकी, और आउटसाइड यानी x इक्वल टू 2 के राइट पे और x इक्वल टू 0 के लेफ्ट पे पॉजिटिव वैल्यूज आएंगी, यानी ग्राफ ऊपर होगा. We are not interested in that. We are just interested in this. So upper graph minus lower graph, and integrate with respect to x, and you can complete it yourself. What's given in 9? 9 says cos 2x. Y is equal to 0. Y is equal to 0 is x-axis. X is equal to pi by 4 is this line. X is equal to pi by 2 is this line. Now, if I consider x equal to pi by 4, what will be the value of pi? Cos 2 into pi by 4 is cos pi by 2, which is 0. What will be the value of this function at x equal to pi by 2? 2 into pi by 2 is cos pi. Cos pi is -1. So that is why I've made the graph like this. So region enclosed by these conditions, curve, straight line, straight line, straight line, is this region. So upper function is 0, lower function is cos 2x. Whereas in the 10th question, secant square, y is equal to 2, y is equal to minus pi by 4, and x is equal to minus pi by 4, and y is equal to minus pi by 4. Sorry, दोनों x values हैं, नजर भी नहीं आ रहा सही, हालांकि मैंने बड़ा किया है इसको. तो x is equal to pi by 4 है ये. मैंने उल्टा कर दिया है इसको. I'm talking about नहीं. This is a condition for ये वाली conditions मैंने इस question में लगा दी. Why not I go to the somewhere where I have space. Okay, I have a space here. So ये जो question number 10 है, इसमें जो figure बनी हुई है सही नहीं है. तो question number 10 की figure हम redraw करते हैं. My trick is first y is equal to 2. Y is equal to 2 is this height. Then x is equal to minus pi by 4. So minus pi by 4 is here. And x is equal to pi by 4, so x is equal to pi by 4 is here. Secant. Secant is 1 upon cos. Square में है, so all positive values. So what will be 1 upon cos minus pi by 4 squared? That will be the y value at x equal to minus pi by 4. So cos minus pi by 4 is 1 upon root 2, that is 1 upon 2, 1 upon 1 upon 2. So यहाँ पर आ गई. What will be the value of y when I consider x right in between? So secant का ग्राफ जो है वो यहाँ से गुजरता है, तो secant square का भी यहीं से गुजरेगा, and we will see that this region will be like this. X equal to minus pi by 4 पे height will be 2 and x equal to pi by 4 पे भी y value जो है 2 आएगी, यानी इस पॉइंट के कोऑर्डिनेट्स pi by 4 2 और इस पॉइंट के कोऑर्डिनेट्स minus pi by 4 2. So the region that I have to consider for integration is this region. And I think now it will be clear कि ये फिगर गलत थी for problem number 10. और अब जो हमें इंटीग्रेट करना होगा वो क्या इंटीग्रेट करना होगा? अपर फंक्शन y is equal to 2 minus lower function is secant square integration over x from minus pi by 4 to pi by 4. Many times when we have this kind of situation and the region is symmetric about x-axis, we can write it as 2 times integral 0 to pi by 4 and 2 minus secant square. And this can be integrated easily. 2x in minus tangent will be the integral and you can complete it yourself. So 11 मैंने डिस्कस नहीं किया हुआ, उसके बाद 12 डिस्कस किया हुआ मैंने. In 12 we have x is equal to y minus 2, a straight line which is y is equal to x plus 2 and y is equal to x square. इन दोनों के पॉइंट ऑफ इंटरसेक्शन निकाल के रीजन रिकॉग्नाइज करना है. Upper region is y is equal to x plus 2, lower region is x square. So I have demonstrated some of the problems from this 12 तक थे. Agar you want more, I will consider, I thought I had this exercise problems somewhere. Is it the same file that I was discussing? Yes, it is the same file. It's not different. Okay, I'll solve some more problems and then share with them with you of this exercise. But I will restrict myself to only problem number 7 to 18. So I hope this problem of finding area enclosed between given curves, the basic technique I have discussed, some more problems as samples I will share with you later in the notes that I will share with you. So that's all about area between the curves. So I close these files. And let's move to what is the problem of volumes by slicing discs and washers. The idea here is to find volumes of different solids. It may be a sphere, it may be right pyramid, right circular cone, or arbitrary shaped objects. Now, when we have some objects which are of arbitrary shape like this, we consider the problem of finding volumes of this is that we draw them along some particular direction, for example, x-axis, and the solid is placed on the xy plane, and then we make slices of the solid. So a slice of a solid is of this type. Somebody said 9/2, yes sir. Or something else. Okay, I was talking about कि एक solid की वॉल्यूम निकालने के लिए अब सॉलिड के हम स्लाइसेस करते हैं परपेंडिकुलर सम पर्टिकुलर डायरेक्शन, और ये जो स्लाइस है इसका एरिया जो है किसी ना किसी तरह से हमारे पास कोई ऐसा तरीका होना चाहिए कि आई वी कैन एक्सप्रेस द एरिया ऑफ वन स्लाइस. एरिया ऑफ वन स्लाइस, द विड्थ इज डेल्टा एक्स. अगर ये सॉलिड एक्स की डायरेक्शन में रखा हुआ है, द विड्थ ऑफ द स्लाइस विल बी डेल्टा एक्स, and the area of the slice should be such that कि हम इसको function of x लिख सकें. If area of a slice is function of x, then you multiply it with dx. Oh, I should not write down dx here. This slice है, and I have this width dx. So when I multiply the area of the slice with the width of the slice, I get the volume of the slice. अगर हम इस तरह के स्लाइसेस किए हुए हमने जिनमें क्रॉस सेक्शनल एरिया भी कहते हैं हम इसको, यानी काटे हैं सॉलिड को, तो क्रॉस सेक्शनल एरिया जो है दैट कम्स आउट टू बी फंक्शन ऑफ एक्स. तो ऐसी तमाम कंट्रीब्यूशंस को ऐड कर लेंगे तो टोटल वॉल्यूम निकल आएगा. एंड दैट लीड्स टू द फॉर्मूला दैट इन केस आई कैन मेक स्लाइसेस ऑफ ए सॉलिड each of which has area which is dependent on x, then I can use this formula to find the volume of such a solid. I'll come to examples. कुछ मैंने बनाए हुए थे examples. I think the file is already open. And ये तो वही file है. दो दफा खुली हुई है. This is not that file. Let me open up Zornal file. Perhaps it will be there. Yes, it is there. I have not converted to PDF. Let me convert it to PDF. Yes, it is there. Now, can you see this volumes by slicing?
Yes, sir.
Okay. So here I have considered this tent-like object, and जैसे कैंप लगाते हैं ना, but I am considering this as a solid. So this red boundary indicates solid of this shape, and it is placed on xz plane, y is vertical, and I make slices of this object perpendicular to x-axis, and I assume that somehow I can express the area of the slice as a function of x, or I can make slice in the direction perpendicular to z, in which case I expect that I can represent the area of the slice as a function of z. But we stick to this and not this. Now, in this case, when I make this green slice, I assume that I will be able to represent the area of the slice as a function of x. The width of the slice is dx. So the volume of the slice is x dx. And if I can integrate from some limit x is equal to a to x is equal to b, I can get the volume. Of course, it all depends कि मैं area of the slice को represent कर सकूं as a function of x. Yes, the question has been asked that should the solid be in definite shape or any type? हजारों ख्वाहिशें ऐसी कि हर ख्वाहिश पे दम निकले. Whatever mathematical techniques we develop or we move on into difficulty levels of the technique, हम किसी भी arbitrary shape के solid का volume निकालना ये बड़े लोगों का काम है, और उसके लिए बहुत advanced techniques की जरूरत होती है. We are here considering, as shown by the heading, volumes by slicing. Only in case we can make slices in such a way that the cross-sectional area of the slice is a function of only one variable, and the width of the slice is represented in terms of differential of the unknown whose axis is perpendicular to the slice. So for example, I consider a sphere. The figure is not very good. Yes, Musa, what's the problem? Yes, Musa. Musa, can you hear me? I'm asking Musa, who's raised his hand.
सर शायद मिस्टेक से हो गया हो.
जवाब तो देना है. पिन हो गया बिना वजह. पता नहीं क्यों पिन हो गया. Anyways, I was talking about कि मैं स्फीयर कंसीडर करता हूँ. स्फीयर का आधा हिस्सा xy प्लेन के ऊपर है, आधा हिस्सा xy प्लेन के नीचे है. My objective is to find the volume of the sphere. We already know that. I hope things are settled. We already know that the area of a sphere is 4 pi by 3 radius cubed. But we want to demonstrate that slicing के जरिए मैं ये formula कैसे derive कर सकता हूँ. So what I'm doing is I'm considering a sphere whose radius is r. I consider a slice in a direction which is perpendicular to z-axis. That means area of the slice will be a function of z. Now the radius of the slice is small a, so the area of this green slice will be pi a square. Now OB, height is z coordinate, and the right triangle OBA tells me that this radius A squared is equal to hypotenuse squared minus this z squared. So that जो pi a square इस slice का मैंने area assume किया था, which has to be function of z. In order that मैंने slice perpendicular to z axis बनाया तो मैं a z d z जो है उसको इस्तेमाल कर सकता हूँ. But pi a square को उससे पहले function of z लिखना जरूरी है, जिसकी वजह से मैंने slice की height z consider की above xy plane, radius or slice radius of the sphere and radius of the slice. So this becomes the right angle triangle. So radius of the slice squared is equal to radius of the sphere minus height of the slice squared. So that the area becomes pi times a square के बजाय r square minus z square, where r is the radius of the sphere. Now this slice, which is circular slice, is perpendicular to z-axis, so the width of the slide has to be vertical direction dz, and the volume of the slice will be then product of this and this. And I integrated from minus r to r. Minus r means sphere यहाँ से लेके यहाँ तक फैला हुआ है. So instead of minus r to r, मैंने अभी थोड़ी देर पहले कहा था, for symmetrical objects we can convert the limits 0 to r and multiply it by 2. And rest is just the integration of this expression, which can be easily done, which takes us to this. So the formula, once you recognize area of the slice as a function of z correctly, select the width of the slide correctly and go for integration over z. So हमने क्या किया? Largest slice is on the horizontal plane, xy plane. As you go up, the slice becomes smaller and smaller and smaller and smaller. All such slices, उनका area is represented by this integral. In a similar problem, I can consider a right circular cone. We know that the right circular cone has volume pi upon a L square. What is A? A is the radius of the base. And what is L? L is the length of the, what I've done. Okay. OA, length of the slide, right circular cone. AB, radius of the base. This is R. Now I have placed this right circular cone, which is a solid, in such a way that it is symmetry axis along y-axis. That means when I cut a slice, I have to cut perpendicular to y-axis. When I cut a slice, the width of the slice will be dy, and the area of the slice, the orange part. Area of the slice is just the area of a circle, which is pi a square, where a is the radius of the slice, circular slice. So area of the slice, which has to be a function of pi, currently is pi a square. A is the radius of this slice. But as I move along the y-axis, this radius will change. How it will change, that I have to understand. Now A is equal to what? ये जो region है, ये जो triangle है, इसको मैंने यहाँ बना दिया. O से लेके center of this slice, B, and top of the slice on the surface of the cone, C. This is the radius of the slice. This is the hypotenuse of this right triangle. This is base of this triangle, right angle triangle. And this base is representing the distance of the slice from origin, which is pi. Now, I can put this for example, सवाल पूछा गया है कि is it necessary to take a specific slice for a particular solid? Yes, when I'm considering a sphere, I can take a slice perpendicular to z-axis, perpendicular to y-axis, or perpendicular to x-axis. In this picture, it was convenient for me to take perpendicular to z-axis, so I did it like that. Here I have made the figure in such a way that the right circular cone has a symmetry axis along y-axis. तो मैं slices perpendicular to y-axis बना रहा हूँ. That makes it easier. मैं slice किसी और angle में बना दूँ, so that will not be helpful for me. I cannot make slice like this parallel to y-axis or perpendicular to z-axis. That slice will not be useful. But this is the symmetry of the figure that allows me to take slices perpendicular to y-axis. Yes, we are not free in the choice of slices. We have to make slices in such a way that the area of the slice can be represented as a single variable. चाहे वो x हो, चाहे वो y हो, चाहे एक single variable. In this technique that we are discussing. So coming back to the value of a, ये जो एंगल है यहाँ पे थीटा, ये इस स्मॉल ट्राइंगल के लिए भी थीटा है और ये लार्ज ट्राइंगल के लिए भी थीटा है. So I can write down A is a quantity that is under consideration, which I have to represent as a function of y, because this area or this radius of the slice will keep on changing as I move along the y-axis. So this A has to be a function of y. Base is y already. H square is equal to A square plus y square. Tell me what? Cos of theta is y upon h. That means h is equal to y secant theta. So h में h square is equal to a square plus y square में h की जगह y square secant square theta लिखा, a square को अपनी जगह रहने दिया, y square. Then y square taken on the other side and taken common, a square is equal to y square secant square minus 1. That means a is y tangent theta or a square is y square tangent theta. So area of the slice, which was written as pi a square, and we have found that a square is nothing but y square tangent theta, where theta is constant. So tangent theta is constant, y is changing. So this is the area of the slice ultimately obtained, multiplied with the width dy, volume of the slice, and then integrate over y from 0 to the length of the right circular cone. Tangent theta, in overall figure, अगर मैं या सिर्फ इसी में it should be हमने radius r लिया हुआ था. This should be r. पूरी ओवरऑल फिगर में देखें तो this has to be r upon l. So this has to be r upon l, and we are integrating along y, so 0 to l integrated. So this is r, this is r, this is r. So y square integrated by cube by 3, 0 to l, and l cube by 3. There is a l already there in the denominator, so it leaves pi by 3 rl square, which is a known formula for the right circular cone volume. And we have developed that formula using slicing technique. Now, we will come to the problems of exercise 6.2, where we'll consider some problems that are solved using slicing, but there are other problems which are solved using another simple technique. Now, what's that simple technique? Consider a region enclosed between these three curves. Y is equal to fx, red curve, x is equal to a, and x is equal to b. Now, region enclosed by this is along xy plane. मैंने शेड नहीं किया हुआ क्लैरिटी रखने के लिए. अगर मैं इस रीजन को, जो कि यहाँ पे स्ट्रेट साइड है, ये स्ट्रेट साइड है, ये कर्व साइड है, बेस स्ट्रेट साइड है, इसको मैं रिवॉल्व कर दूं अबाउट एक्स एक्सिस. सो ये ओवरऑल शेप जो ग्रीन सर्कल इस पॉइंट से बनेगा, ग्रीन सर्कल इस पॉइंट से बनेगा, हर पॉइंट से एक सर्कल बनेगा. And I will have a solid which is called solid of revolution, because I have obtained the solid by
revolving a region in xy plane about x-axis. I can develop solid of revolution by revolving a region about y-axis or about z-axis, whichever is appropriate in a particular situation. But right now, जो कुछ हमने consider किया हुआ है, y is equal to fx, x is equal to a, or x is equal to b. This is the region of xy plane, first quadrant. We revolve it around x-axis 360 degree. Each point on the curve y is equal to fx describe a circle around x-axis. Center of every such circle will be along the x-axis. So in this region is revolved around x-axis, we get a solid of revolution. Any slice of this solid perpendicular to x-axis is a circular disk. जिसका area जो है, that will be pi r square, because this is a circular disk, और इसकी width जो है वो dx होगी. So that means हम solid of revolution को slicing के जरिए ही handle कर रहे हैं, और इस तरह से कर रहे हैं. This point has a distance y from x-axis. अगर इस point को मैं revolve कर रहा हूँ around x-axis, जो सर्कल बन रहा है उसका रेडियस जो है वो y ही रहेगा या fx रहेगा. So pi r square, the radius will be y or fx square. So the slice of the solid of revolution has area pi fx square. The width of this slice is dx because it is perpendicular to x, dx. And when I consider sum of all volumes of these kind of slices, add them together, I get the volume of this solid of revolution. And we see that there are, due to area, which I want it to be function of a single variable, and the construction has given me that that function is just y is equal to fx, which is one bound of the region which is being revolved. So area of the slice comes out to be pi fx square. And when I integrate over x, I get the area of the solid of revolution. And this is the basic formula for area of solid of revolution if y is equal to fx along with these limits is revolved around x-axis. But if I have x is equal to gy curve along with y is equal to c and y is equal to d, and the region is revolved around y-axis, I will have a corresponding formula pi function of y whole square into dy. So wherever I can consider a solid to be a solid of revolution, I can use this technique. For example, I'm want to go back to that circle problem, sphere problem. Sphere can be considered as solid of revolution. Upper part of the sphere, y is equal to square root of a square minus x square. Y is equal to minus square root a square minus square to lower part of the circle. अब अगर मैं इसको revolve करूँ x axis के around, तो I will generate the sphere. So y is equal to square root of a square minus x square. From x is equal to minus a to x is equal to a, revolved around the x-axis, I will get the solid of revolution, which is nothing but a sphere, because this is half circle. So square of y, which is a square minus x square multiplied by pi integrated from minus a to a. Symmetry की वजह से limit 0 to a, or twice of the integral pi times a square minus x square, and we get the same formula after integration is completed, 4 by pi by 3 radius cube. इसी तरह राइट सर्कुलर कोन जो है उसको भी मैं सॉलिड ऑफ रेवोल्यूशन कंसीडर कर सकता हूं, बट व्हाट काइंड ऑफ सॉलिड ऑफ रेवोल्यूशन? This line, which makes angle theta, is y is equal to mx or x times tangent theta, which is the slope of the line. If this line is revolved around x-axis, we will get the right circular cone. So now it's a problem of revolving this line around x-axis between x is equal to 0 and x is equal to L, the length of the right circular cone. So y squared means x squared, tangent squared. Now what is tangent? Tangent theta, the radius of the base, length of this. So A upon L. So A upon L x integrated x cubed by 3 pi times x square constant A square upon L square A square upon L square x cubed by 3, and we get the same formula. And then we come to some problems in exercise 6.2. That's it for me. Can't sit more. Have some problems in my eyes, in my back, in my heart, in my shoulder. For a long period के लिए मैं काम नहीं कर पा रहा हूँ. We have laid down the principles for solid of revolution, and we will apply these things in exercise 6.2, problem solving. And some of the problems will not be solved using solid of revolution formula. We will have to force the slicing technique, and I will discuss these problems, inshallah. दुआ करना मेरे लिए कल मैं दिन में मेरी सूरत हाल बेहतर रहे, so that I am able to take class appropriately. और कल है ना हमारी क्लास रेगुलर? कोशिश करूँगा कि 3 से 4 बजे तक क्लास ले लूँ, या 4 से 5 तक ले लूँ, अगर तुम लोगों के पास टाइम हो. But I'm recording all these sessions, and जैसे ही मुझे हिम्मत होगी मैं क्लास रिकॉर्ड कर लूँगा. Thank you very much for being with me, and now I'm stopping the recording first.